Hello, welcome to our channel for probability and statistics. In this video, we will explain stepwise regression. So we know in regression analysis, we build a model and want to include which variable will be present in the model. And sometimes there are concrete reasons to include several important variables in the model based on previous research questions and the results. And in other case, we will include the several primary variables based on the sample data. So in such a situation, one kind of approach called stepwise regression can be used. And for talking about the stepwise regression, we have to first understand the forward selection and backward selection, or backward elimination. So these two opposite process. So the forward selection is start with only one variable, or start with a simple linear regression. So we will find the largest regression sum of squares for this variable if we include one of these variables in the model. So say if x1 gives the largest value of r square is the coefficient of determination. So this is the variation of the model to explain the variation of the observations of the y variable. So in this case, we will start with x1. And next, we will test if x1 is significant, the coefficient is significant or not. So if x1's coefficient is not significant, so the process will be terminated. So there is no possible model. So if x1, which gives the largest value of r square and it is significant, then we will continue in step 2. So step 2 will choose one of the rest of the variables given x1 is in the model. So this will based on, we will calculate several models which include xj. So xj is the rest of the variables except x1. So say if we get how to calculate the r square. So r square xj given x1. So x1 is the coefficient is beta 1, right? So we will calculate both x1 and xj in the model, then minus the r square of the model only x1. So this is the r square increment. So the variation explained by the model, but this is the marginal increment coming from the variable j, right? So we do this process for all the other variables. Then we will get r square, which is the best one, the largest one. Then we will include this variable in the model in addition to x1. So for example, x2 has the largest r square. Then we include x2 in the model. Then next we will test if x2 is significant or not. So if x2 is insignificant, so the process is terminated. The model has only one variable, one independent variable, x1. So if not, which means x2 is also significant, then we go to step 3. So we process this step and so on until there is no more variables will be added into the model, then the process is terminated. So this is forward selection. And this model is continued until the most recent variable insert fails to induce significant increase in regression, right? And such of the test, significant or not, is based on the f-test. So f-test, for example, we have one variable beta 1, then we add beta 2 or add x2. Then this test, f-test can be done with r square increment from x2 divided by s squared. So s squared is the mean squared error for the model, including x1 and x2. And for the third step, similarly, r squared increment from beta 3 from x3 divided by s squared. Here s squared is the 3 variables included in the model. So all these f-tests will determine if this variable is significant or not, right? So there are degrees of freedom in each step of the f-test. Here n is the number of observations, and 3 is 3 parameters. So this is a forward selection. And what is the backward elimination? This is the opposite of the forward. So backward, we select all 5 variables, for example, in the model first. Then we will calculate if we remove beta 2, for example, then we will get f-test if it is significant or not. If we can remove this, then we'll get the decrement of beta 2, right? So if the test is insignificant, so which means we remove this one, and the model will not be worse, right? So we just can remove this variable. So and so on, this process and so on until there is no more variables can be removed. So if we remove this variable and the decrease of the r square, margin r square, is significant compared with the s square f-test, then we cannot remove this one. So if only insignificant for f-test from removing one of the variables, then we can remove this. But we will find the biggest one, r square removed. So this step is backward step. So stepwise regression is combined with is a forward type. But in each step, in addition to add one variable into the model, we will test all the variables again. Because, for example, if we add one variable beta x2 in the model and with the current variable x1, so also in the previous step we have tested x1 is significant, but because we add x2 in the model, we have to test x1 again. So this is the stepwise. So each step, some of the variables can be removed with the addition of another variable. Then again, in the next step, we will also choose this removed variable again to the model. So it's quite complicated, and stepwise regression can have multiple times of addition and removing of one single variable into the model in different steps. So we will show an example which estimates the length of infant based on the weights and several variables of the infants at the birth date. So we do not show the table, but we will show the calculation. So consider each variable separately for individual simple linear regression equations fitted. Because in the first step, we will have 4 independent variables to select. So we have to estimate 4 simple linear regression with only 1 variables. And the following is the regression sum of squares. So r square for each variable. So variable x1 clearly gives the largest regression sum of squares. This is the largest. So this is the candidate for inclusion in the first step of the model. And the mean square error for the equation is S1 is this number. So we will test if it is significant to include this variable in the model. And we get f value, and for 1 f-test for the 1 and 7 degrees of freedom, because we have all 8 observations, so here is 7. And this number is significant. So x1 is included in the model for first step. And step 2, there are only 3 variables left to evaluate. So we again will test R² for 3 models. Each model has 2 variables, x1 and one of the other of 3 model variables, right? So 3 equation gets R². So x3 here has the largest increment of coefficient of determination. So this is the candidate variable to include in the model in the second step. Then again, we test with the F statistic if we include x3 in the model and with x1. So this is the number, and now the degrees of freedom is 1 and 6 for the F test. Again, this is also significant that we include in the model. Now we have to subject x1 in the presence of x3 to a significance test. Why? Because this is not a simple forward, because we use stepwise. So because we have added x3 in the model, we have to test x1 again here. So test x1 is using this form, and this is the test for f. So x1 is also significant with the addition of x3 in the model. So step 2 is completed, and both variables x1 and x3 are significant and have to be included in the model, right? So in the step 3, because x1 and x3 already in the model, we now require 2 equations for the linear regression to estimate if we can add x2 or add x4 in the next step. And we calculate R² for these 2 variables. If we add this in the model, I can see R² for beta 2 for the x2 quite small, and for the x4 is also quite small. And S² for these 2, neither is significant at alpha is 0.05 level. So we will stop at this step, and the final regression model will be having 2 independent variables, x1 and x3. Then we can estimate with the coefficient, and the final R² for determination is about 0.9882. Just one comment of this process. So because the stepwise regression is graded, right? Because in the first step we find x1, and x1 then we add x3, right? And we will not consider other case. For example, if we add x2 first, or we add x4 first, or add x3 first. In many kinds of combinations of the model, we just start with the x1 first. So it is not necessary that this result will be the optimal case of all possible models, because all the possible of the model is about 4 times 3 times 2. There are about 24 different models, but we only consider starting from x1. So this is a graded process, and not necessarily the complete optimal result will be found. So we just note, but it of course will be very close to the optimal, or maybe the best one. So we have to note this, because of course this is also from the sample data. We only from the sample data, this is random. If we get different samples, we'll get different results. So this is maybe the best case, optimal case, what we can do compared with the time cost and the precision what we can get, right? So this is the stepwise regression. Thanks for watching.